Okay, so this is what we were talking about yesterday. Okay, that relationship between mean, median, and mode. So when you say data is standard, normal, no deviation, nothing, nothing, there's no skewness, that means data could be like this. These are your symmetric. That means mirror images. Okay, so it could be something like this. The first graph you see, it is unimodal. You have only one mode here. Okay, and data increases to a point and then starts decreasing. Okay, so this was the type of example that we did yesterday. The data could be uniform. It's called uniform graph. Uniform means it's the same value. It's either 0 or 5. There's anything in between. So so you have either 5 or 0, right? Nothing in between. Let's say if the arrival of a train, okay, metro train is, let's say, scheduled to arrive every 10 minutes. So it's like 0 and then 10. So the time of arrival between two metro stations will be uniform. If there is no delay, as such, then the time between two metro train will be uniform. It says every 10 minutes there is a train coming, right? So it will not be 8 minutes or 12 minutes. It will be 10 minutes. So data can be uniform. So either 0 or 10 or 5, whatever. Then this is another kind of data which is inverse of first one. So here it is very easy to get extreme data, but difficult to get the average data. So this is your bimodal where you have maximum values occurring at the extreme ends. Okay, very difficult to get. Yes. So the average. So this could be your symmetric or regular graph. But things can change. This is what we saw yesterday. Things can change when, okay, the graph was normal. The middle graph you see, this is what the graph was earlier. This is what the numbers were earlier. But if you add a number on the left side, okay, if you add a outlier, right, outlier on the left side, okay, let's say if this ends here, you add somewhere here, okay, much higher value. So what happens? You get a tail on left side, and when you get a tail on left side, it is going towards minus x-axis. So we call it negatively skewed graph. Okay, in negatively skewed graph, mean will be less than mode, median will also be less than mode, because you have a small value that got added. So everything, mean and median, will move towards left, but mean is moving at faster rate than median. So median will be between mode and mean, and both will be on the left side of the mode if it is negatively skewed graph. If it is positively skewed graph, mean and median will be on the right side of the mode. Outliers, okay. Mean is increasing, it is positively skewed. Okay, so you are adding on the higher end, on the right side, higher end of the data. So tail is going towards right side. Okay, so what is this graph? This is histogram graph. This plot is histogram. In histogram, you plot the count, right? This is your count occurrence. So when you have one extreme outlier, so count will be very less, 1, 2, right? So that's why you will see a tail on right side or left side. Right side means positively skewed because it's going towards the tail. Okay, look at always tail. Tail is going towards positive x-axis. Okay, this is called skewness, and this is the formula to calculate. We can see in Python how to calculate later. Okay, and skewness. So we say that if the skewness value is more than +1 or -1. -1 means in negatively skewed graph. +1 means positively skewed. If value is more than 1, we say highly skewed graph. And if it is between 1 and 0.5, we say it medium skewed. Okay, less than 0.5, we say almost no. I mean, okay, very less skewness. Value can go any side. Okay, it can go much higher than 1. Okay, but more than 1, we say highly skewed. Okay, next we talk about measure of variability. So we're talking about measure of central tendency so far. Okay, that means you have a center and how far are you deviating from center. So yesterday before we closed, I gave an example, right? So if I say instead of starting at 7, one day I start at 8 o'clock, another day I start at 6 o'clock, the class. And if you question me, I'll say, see, average is 7. If you take average of my data, you get average 7, perfect 7. So I'm starting class at 7. Does that mean I'm starting a class at 7? No, right? So here you're talking about the range or the variability. How much deviation is there from the expected value? So sometimes your mean and median may also not give you correct result. Okay. So we look at dispersion. So along with the central tendency, we should also look at variability. How much is the variability in the data? Okay. And variability is big factor when you make decisions. In life, we don't prefer variability. We don't want variability for any that matter, that is positive or negative. Okay. We don't want variability in life, right? So what we try to do is we try to reduce the variability. The Six Sigma the concept itself, right? Six Sigma syllabus, or what you call the study itself, is based on variability. It's so important not to have variability in the process that we have a separate study itself. Okay, so sigma is basically how to reduce the variability. Okay, so we are trying to reduce the variability. So one way, one of the metric, just like we had mean, median, mode in central tendency, in variability, one of the basic metric is range. Range will tell you difference between minimum and maximum value in the data set. Okay, so so again, same example. Okay, if I tell you that, see, I'm coming one day at 6, other day at 8, but if you take average of 6 and 8, you get 7 only. Correct? You get 7 only. So you'll ask me, what is the range? What is the minimum and maximum value, and what is the range between them? So range is 2 hours. Then you say, oh, range is 2 hours. See, it is not a good data. Okay, if average is 7, but range is 10 minutes, acceptable. But if your range is 2 hours, not acceptable. So that's why range is another important metric. Okay, so along with mean, you'll also ask for range. Okay, so range is simple. Okay, maximum minus minimum. So if you look at these two data set, in the first data set, range is 100 minus 5, 95. In second data set, 100 minus 21, right? So in this case, the range is much less. So the spread or variability in data 2 is much less compared to data 1. Spread variability is much less in data 2. Yes, everyone? Okay, so this is how range works. Okay, now sometimes we might have extreme and outliers, right? Just because you have one outlier, just because, if you talk about maximum minimum, let's say, every time I come at 7, just once I came at 8. So because of one bad data, my range will be very bad. Most of the time I come around 7 o'clock only. One day I come at 8 o'clock. One day out of 50 days, the range will show very bad data. So that's why what we generally do is we don't look at range, but we look at interquartile range. Okay. So I'll tell you what interquartile range is. Okay. We try to leave out outliers. Because of one or two outliers, your data might look very bad. But that's not the case. Out of 100 or 1000 data, just 2 data is bad. Entire data will look bad in case of range. Okay. So that's why we generally don't prefer range. We prefer IQR. IQR, interquartile range. Okay. So what is interquartile range? Okay. Let me show you. All of you should be able to see my paint now. So we divide the data into 4 parts. Okay, what metric divides data into 2 parts? What metric divides data into 2 parts? Which metric divides data into 2 parts? Median. Yes or no? Median will divide your data set into two halves. That's what we said. Median means mid value. Right? So if you have a data set, you find median. And now you take this data and you find median of this data. Okay? And find median of this. Okay? So this is not called median. Okay? These are called as quartiles. Q. Quartiles. Okay? So quartile is half of median basically. Okay? So this is 0. Let's say your first 0 data, and this is your 100% of data, right? 0%, 100%. 0%. Means this is your first data, this is your last data. So median will give you the 50% of the data, right? 50% of the data. Okay, that means left of median has 50% and right of median is 50% of the data. Now I'm doing the quartile. Quartile means here you have 25% of the data. Okay, here 25% of the data, here 25%, here 25%. Okay, so these are called quartile. This is called Q1, quartile 1. This is called Q0. Q0 is your lowest value, or 0%, lowest value, Q0. Q1 is first quartile, 25%. So between Q0 and Q1, you will have 25% of data. Okay. Median is also called as Q2, quartile 2 or median. Median is same as Q2, quartile 2. Then this is your quartile 3. Quartile 3 is median of median. So, and this is quartile 4. So quartile 4 is same as 100%, same as maximum value. Quartile 0 is same as 0%, same as minimum value. Median is same as quartile 0 or 50%. Quartile is same as, quartile 1 is same as 25% of the data. Quartile 3 is same as 75% of the data. Okay, so if you divide the data into 4 parts, you get Q0, Q1, Q2, Q3, Q4. If you divide the data into 2 parts, you get median. If you divide data into 100 parts, what do you get? If I divide data into 100 parts, percentile. You see that in GMAT and other things, right? CAT, percentile. Percentile is dividing the data into 100 part, and you're saying percentile. Centile means 100. Per 100, that's what it means. Per 100 is your percentile. Okay, so percentile means you're dividing data into 100 parts. So 0%, 1%, 2%, 3%. This is 25%, or 25 percentile. 25 percentile is same as quartile, first quartile. 50 percentile is same as median or second quartile. 75% is same as third quartile. 100% is same as fourth quartile. 100% means maximum. So if you say that I got 100 percentile, that means you are topper of your batch. Okay, so percentile talks about rank. 100 percentile means you are topper of the batch. 90 percentile means what? 90 percentile. That means you are above 90% of the student. Your rank is 1/10 of the total student that has appeared. So if 100 student appeared, your rank is 90. If 10,000 student has appeared, what's your rank? (90 percentile). Okay, if 10,000 students have appeared for the exam and your percentile is 90, what's your rank? So see, if you're, so if you have 100 student, your rank is 90. That's what 90 percentile means. If okay, if you have 1,000, it is okay, not rank, it is that many people below you. Okay, So your rank is 100 minus 90, 10th rank. So if you have 100 student and if you have got 90 percentile, that means your rank is 10th. Okay. If you have 1000 people, that means 90 percentile means there are 900 people below you. 900% people, 900 people below you. Your rank is 100th. And when it is 10,000 people, then your rank is 1000. Okay. 90 percentile means there are 90% people below you, 10% people above you. So if you have 10,000, what is 10% of 10,000? 1,000. So your rank is 1,000. Okay. So this is how we divide the data. Okay. If you divide into 2, it is median. Divide into 4, it's called quartile. Divide into 100, it is percentile. Okay. Okay. So now coming to quartile, what we say IQR, interquartile range. So what we are saying is that instead of looking at range, instead of looking at 100 minus 0 percentage, let's divide, okay, or let's divide into 4 parts and perform Q3 minus Q1. Perform Q3 minus Q1. No, it's not median. See, if the data is like 1 and this is 100, your median will be 50. So this is 75. 75 minus 25 means 50% of data. But median is from here to here. Interquartile range is from here to here. 50%, but it's not same as median. Median is from 0 to mid. Median is from 0 to mid. Okay. And quartile is from Q1 to, so both are having, so if you have total of 300 data set, if you have total 300 values, okay, midpoint will have 150 data this side and 150 data this side. Okay. But IQR will have 75 from here and 75 from here. It will also have 150, but 75 from here and 75 from here. So the general tendency is that you are leaving out outliers. You're leaving out outliers. So IQR is required to leave. Also, you're leaving out 25% data on the left side, extreme end, 20% on the extreme right. So range sometimes, okay, is not good metric because it can include outliers and your data might look very bad. Because of 1 or 2 false data out of 300, 500, 1000, it might look very bad. So we say, okay, let's not look at range, let's look at IQR. So IQR is your interquartile range. Interquartile range means you are dividing data into 4 quarters and you are taking the difference between Q3 and Q1. That is your IQR. We are leaving out 25% data on the left, on the one end, and 25% on the other end. Okay, so we leave out 25% on either side. Okay, in that way we are taking care of outliers. So IQR is a better metric than range. Yes, everyone? Yes or no?
Yeah.
Yes.
Yes. Okay, so this is what IQR says. You leave out 25% on the left, 20% on the right, and the middle 25% plus 50% is what you consider as IQR, Q3 minus Q1. Okay, so now it talks about exclusion minus inclusive, doesn't matter. What it says is, okay, this is like exact calculation. When you come down to calculation, so when you say IQR, should you leave the quartile or should you include the quartile? So both are valid ways, okay? You'll get little bit here or there, see here. So this is like, see if this is your median, okay? In this case, it is fine. There's no question of inclusion or exclusion. But now if you find the quartile, okay, Q1 is 57. So 57 should be on the left side or right side? Should it be included as Q0 or Q1? So inclusion method says this 57 should be included. Exclusion method says 57 should be excluded. But doesn't really matter, okay? It's yes, in quartile. So this is exclusion method. In exclusion method, what we do is we do 81 minus 57. Okay, in exclusion method, okay, we do, okay, you have a value in between. So we exclude 57. You include 60, 77 minus 61. 79? Where did you get 79? Okay, average, sorry, average. Yeah, you get average of 57, 61 is 59. Correct. You do inclusive. So it comes down to actual calculation. Okay. So that's fine. But you understood how, right? Okay. So now we're talking about next important plot. It is called box plot. What is box plot? Box plot talks about your quartile. Okay. It talks about quartile. So let me draw a box plot and then we'll see how it looks like. Okay. Box plot, it can be sleeping box or standing box, doesn't matter. Okay, let's do first sleeping box. So you have a box like this, rectangle. Okay, if it is standing, you will have a box like this. You will have a line in between, anywhere. Okay, and then you'll have a handle at both the end. This is how a box plot looks. Sleeping horizontal box plot, vertical box plot. Okay, so this is your box. Okay, now this talks about your Q0, minimum value. This talks about your maximum value, Q4. Okay, IQR is your box basically, Q1 and Q3. Okay, and this is your median. Median is represented as a line inside the box. And the end of box is your Q1, Q3. And a handle is your minimum and maximum. Same thing. This is your Q4, Q3, Q2 or median. Okay. And this is your Q1. And this is Q0 or the lowest value. Okay. This is how box plot is represented. Some box plot will have some dots also here. These dots are outliers. So box plot is the only plot which will identify outliers and mark it on the plot. No other plot will identify outliers. We talk about histogram. Histogram, if you have, like we yesterday we discussed about that example. The household median household income of people in US, right? So if you go here, these are outliers, isn't it? But histogram has treated it like a normal value. Every plot except box plot will treat it as normal data. Okay, histogram, you saw, that's why you have a tail. See, if histogram was able to identify outliers, then it will never create tail. Okay, what it will do? It will create something like this, and then it will say, oh, there's a dot here, outliers. It does not identify. So it is treating outliers also as data. That's why we're getting tail. We're not getting a perfect or normal graph. Box plot will identify. Box plot will not include outliers. Okay, box plot will mark it separately. So this is the only plot which will give you outliers. So coming back to our discussion here. Okay, so okay, so these are the 5. Okay, 5. Each box plot will have 5 marking. Lowest value, handle, Q1 or 25th percentile as the starting of the box. Median or 50th percentile or Q2, which is the line in the box. Q3 or 75th percentile, end of the box. And the highest value or Q4 at the handle at the other end. Okay, so this is how it looks like. Okay, lowest value Q1, median Q3, and highest value, and this is box is your IQR. Okay, yeah. Okay, and this is how you will see the box here. Now, see, tell me, what does this box indicate? Okay, why do you think this line is long? Too much? Too much data is excluded. What does that mean? So see, box plot or your IQR doesn't talk about the range of the value. It talks about the number of data points. Median is what? Number of data points. Quartile is number of data points. So, between this point and this point, you have 25% of the data, but range is too high. Yes, between your first and the 25th percentage. Let's say if you have 100 data point. Let's say you have 100 data point. So this is your 25th data point, and this is your first data point. So range between first and 25 is too much, and between 25 and 50 is very less. Between 50 and 75 is even more less, and between 75 and 100 is even more less. So it is a range of the values. Okay, the long line indicates range, and it is like if you have longer, the density is less. Density means number of values in that range. Number of values will be same. Each of these 4 will have 25 values. Number of data points n, it's all 25, 25, 25, 25. But the values are too much. Range is high. So that's why you see. So it says that if you have negatively skewed tail, okay, so you will have long, handle on the left side. Okay. So example, if you see here, okay, so this is the amount of, so this is an example where people, it's an example of how people eat on weekdays. Okay, so they have taken, per person expenditure of their food, and okay, let's talk about it. Okay, so this is the lunch expenditure, okay, of people. So they have maybe surveyed 1,000 people, and this is what they have figured out. So they have asked them on each of these days, how much money do you spend on lunch? And they have plotted this graph. So what do you tell? What do you get from this data? Let's see. What can you tell from this graph?
On Saturday and Sunday, they will spend more.
How do you say that?
Because of on y-axis, total bill increasing. No, that's why. Is that so? I don't know. I'm just guessing.
No, there's nothing to guess. You have data in front of you. First, look at median. Okay, what does median say? Median of Saturday, Sunday is higher. Okay, and median of Sunday is higher than everybody else, right? So what you said is right. On Sunday, okay, people tend to spend on average higher value. Okay, but if you see here, the lower value on Saturday is also lower than all. That means on Saturday people spend varied. That means on the lowest bill is like $5 or $2 also, and highest is 40. But if you talk about Sunday, highest is higher, right? Almost like $8-9. Okay, so what it means is the spread on Saturday is much higher. People tend to spend very less also and very high also on Saturday. Okay, very less also, very high also. But Sunday, generally the values are much higher. Okay, one. Second thing, the range that you see. Friday, people know how much to spend. The range is very less. Okay, so very less range means, okay, now if I ask we are here, what, 5 of us? And if I ask all of us to think of a number. If all of us think of a number which are very close to each other, you will get box plot like this. Lowest value here, highest value here, since these are very close. But if we tend to guess number very far off, you'll get a box plot like this. Average lower value is 2, higher value is like 40. So this range, okay, tells you how much is the spread in the data. Median, if you look at, yes, Sunday is highest, Saturday is second highest, maybe Thursday is third highest, Friday is lowest. Okay, but in terms of spread, Saturday has a highest spread. People tend to spend lowest also on Saturday and highest also on Saturday. So the highest point is also here. But Friday, if you see, it is also on the higher side, it is lowest, and the lower side, it is highest. Right? That means people are very, they spend almost similar on Friday. And these dots are outliers. There's some, so if you see Thursday, people spend least, but there are some people who spend high also on Thursday. Okay, so if you talk in terms of variability, which is least variable? Friday is least variable. Least variable means we can easily predict. Okay, here you see Saturday here has higher variability. Sunday also has higher, but Saturday has highest. Okay, and Thursday there are some outliers. So otherwise values are less, but some people tend to spend more. Okay. So yes, you have these notes, you can read about it. So here people's heart rate by kind of activity. Okay, let's see this. So this is the heart rate measured on y-axis and by different activity. So now you tell me what you understand from this box plot. Variability is high, but see, while running also, your heart rate which is like 85.
Yeah.
Correct?
Hmm.
So heart rate generally by running is high, but on the lower side also it is lower than walking and resting also. Some people at rest also have high heart rate. See, you have 1/4 of people having heart rate between 95 to 100 while resting also. While resting also they have heart rate 95 to 100. But here you see, it's not the case. Okay. So the variability has, why do you think there's why so much of variability in running? Why shouldn't it be all top only? Why it is like spread from bottom to high? So people who keep running regularly, right, their heart rate will not increase even if they start running. If you are if you do regular running, your heart rate will not increase. Okay, sports personalities, their heart rate will be very less. Okay, even if they run, the heart rate will be low. So people who are more practice of running, they have do more physical activity, their heart rate will be high. Somebody who's new, first time running, will have a heartbeat of 140, 150 actually. First time running, or high heart rate, yes. Okay, so this is what it says. Minimum spread is less in rest, higher in running. Okay. So there's another data set here. So there are 40 students in a class, and this is their heights in inches. These are heights in inches. And these are girls in the class, another 40 girls, and these are their height in inches. So you can construct a box plot. Okay, so height of boys is this, height of girls is this. What do you get from this? On average, boys are taller than girls, right? right? So IQR for girls is higher. IQR for girls is like 5 inches. So that means girls have higher variability in age than boys. Okay. Okay. So we have seen IQR and range. The third metric is called variance. Okay. It's called variance. Variance is the third metric, okay, using which we use to find the variability in a data set. Okay, what is a variance? So for that, let's take a data and then you'll be able to understand better. Okay, so let's talk about, okay, a car distribution center guy, okay, or what do you call the car, the showroom guy, okay. Now, their customer 1, 2, 3, 4, okay. So let's say there are 10 customers. Okay, expected date. He's promising to everybody that car will be delivered in 20 days. Okay, he's saying 20 days to everybody. This is the expected date of delivery. But actual, if you see, this fellow was delivered in 15 days only. 15 days. Here also 15 days. Here 25 days. 25 days, 25 days, 15 days, 25 days, 15 days, 25 days, 15 days. Okay, this is actual. Never ever this guy delivered on 20 days, right? Some cases delivered before the date, some cases after the date. So what is the difference? Okay, so difference you will say 20 minus 15, right? So 5. Okay, so for each case, the difference is 5, 5, minus 5, minus 5, minus 5, minus 5, 5, 5, right? I want to measure the performance of the whole process. Okay, how 5 days? So what I'll do is, I will do the sum and average, right? So what I'll do sum, right? Sum is what here? Sum 0. And average will be what? 0 by 10, 0. So what do we get? Equal to 0 by 10. What do we get? Looks like there is no deviation in the process. On average, there is no deviation in the process. Correct. Okay. So it means that, you'll say that, see, the performance is perfect. There's no difference. There's no deviation. So this is called difference or deviation. Okay. And what we did is called average deviation. Average deviation or average difference. What is average deviation? 0. Process, best process. Is it really best? No. Right? Because we said deviation is deviation, whether it is 5 days or minus 5 days or plus 5 days. So what we do is, okay, so in first measurement, this is the first way to measure, we find deviation, absolute deviation we call it as. Absolute difference or absolute deviation. This is first method, okay? So absolute deviation. Absolute deviation means if it is plus, it is plus. But if it is minus also, if it is plus. Right? So in this case, okay, so we will do into -1 into, this is how we calculate the absolute value, right? Absolute value is positive, right? So this is where we use absolute value. In school, you would have realized why are we doing absolute? This is why we do absolute. Okay, deviation is deviation. So this is your mean deviation. Okay, average is called mean, right? This is your mean deviation. This is your absolute deviation. Okay, so what is sum now? Sum will be 50 and average will be, okay, 50 by 10, right? 5. So this is called as mean absolute deviation, MAD. This is called mean absolute deviation. You found absolute deviation and then you find the mean. So you're saying on average, this is the deviation. Okay, so this is first method. Second method says when you have negative, better to do the square. See, one way to make negative number positive is find absolute. Second way to make negative number positive is to find square. So what you do here, you say square. Okay. So this is your square deviation. Okay. And now if you do total, what you get? 250 and average is 25. This is called mean square deviation, MSD. This is your variance. This is what is variance in data science or statistics. Variance. What is variance? On average, how much are you deviating? Okay. So one is you do absolute. What absolute? Whole data set. Variance is always a whole data set. Okay. No. Variance is always for whole data set. Okay. So it is mean square deviation or mean square difference is called your variance. Okay. But variance is generally not considered as a metric. Why? Because you started with 5 and you got 25. You started with apple, you started and ended with apple square. The metric should be same, isn't it? Metric should not be different. You start with x and you're ending with x square. It's not comparable. You have to perform square root of variance. Okay. So square root of variance is called standard deviation. So you take the variance and you perform SQRT. Because since we took the square, now you're performing square root. So this is called standard deviation. That's why actually variance is the whole process that we perform to calculate. But we don't generally talk about variance. We talk about standard deviation because standard deviation is the same unit. You started with x, you became x square. Now I'm doing square root. So it became x only. Yes. So that's why standard deviation is considered to be the main metric, not variance. Okay. So first method is you directly do the add and divide and you get the average deviation. Okay. Second method is another method to convert negative to positive is square. In fact, most of the time, most of the things, if you see, if you talk about how to convert negative to positive, they'll tell you about doing the square only. So that's why variance and standard deviation is more preferred over MAD, mean absolute deviation. We generally prefer standard deviation over mean absolute deviation. Okay, these are the metric that we'll be using in regression algorithm. Okay, so don't forget, exactly same thing we'll do in regression. So mean absolute deviation, mean square deviation, variance, and standard deviation. So standard deviation is actually, and this is also called as root mean square difference or deviation. This is MSD, correct? Root of MSD is RMSD. Root means square deviation. Okay. So, standard deviation also called as root means square deviation. Root means square difference. Okay. So let's go back to our discussion. So the third metric is variance, but we generally don't look at variance. We go and we calculate standard deviation. This is the formula for variance. Okay, what we did, x minus mu. Mu is the expected value, the average 15. So we performed x minus mu and we did whole square, right? By total number, and then this is variance square, right? To find standard deviation, we did the square root. So this is your variance. Variance is this is your variance, right? We did x minus mu whole square and we added summation. And after adding, we divided by n. Okay. So this is called your variance. Now, we perform variance this way because we have all the data set. So we're talking about 10 data set. We have all the data sets. We perform this. Sample is done when do you do sample? When you don't have access to all the data set. If I'm trying to predict how much seats each political party will get, I cannot go and talk to every individual. So out of 1 crore, I'll talk to 20,000 or 30,000. And based on that, I'm going to calculate my analysis. So in that case, okay, we don't go for, see, when you have all the data in your hand, that is population. But when you have subset of data, when you don't have all the data, you have to work with sample. So if you see here, difference is on the top, numerator is same, but in denominator we did n minus 1. Why we do n minus 1 is, let's come back to this example itself. Now, since we have access to all the data, whatever we have done, we are very confident. We are right, standard deviation is 5 only. But let's say I tell you, we have actually 100 data from the same company. Same car showroom, we have 100 data, but 90 data is not visible to us. 90 data, we don't have access to 90 data. We have access to only 10% of the data, 10 data. So now you tell me, we found this standard deviation. Can you be confident about it? Can you be confident about that standard deviation of the process is 5 or not? No, you cannot be. You don't have all the data. If you don't have all the data, how can you be confident? Right? Are you sure about 5? Is 5 the standard deviation of the entire process? Okay, the whole process is about 100. Guys, speak, no? Why are you so silent? Am I talking something different? Am I talking something which is very difficult?
No, sir.
So I'm saying, is this 5, okay, is this 5 indicative of the entire process?
No.
No, it is not indicative of entire process because we have 100 data, only 90 is hidden. How can you, based on 10, how can you talk about all the 100? You can't, right? So that means there is error in this. Okay, error means should the standard deviation will increase or decrease? Come on, if you have error, so standard deviation value should increase or decrease? Think, I have done the entire process in front of you. So if there is an error, we know there is error. We know there is an error, right? So error means what? You become less comfortable. You become less, sure about your work. So should you increase or decrease?
Decrease.
Decrease.
Increase. Deviation. Deviation means what? Error. Deviation. How much deviation? See, you go and write an exam, okay? Maths exam. You get 10 questions for 10 marks each. Okay. Now, if you are, if you know about each question, okay, that I'm going to get 5 here, I'm going to get 100 here, I'm going to get 0 here. If you are sure about all the 10 questions and you are calculating around, let's say 75, your actual value will be 75, near about 75 only, because you are sure about all the answers. If you're sure about all the answers, oh, first one I got it half correct, second one I got full correct, third one I did not get it. You're sure that you're going to get 5, 15, 0, so on. So you're calculating getting 75. So you're sure that you're getting 75. And actually you might get 73, 75, 76, 78. You will not get 100 or 50. Right?
Yeah.
But let's say in 10 questions, you're only sure about 50. 5. I mean, you're sure about 5 questions, not sure about 5. And then you calculate to be about 70. In this case, you can get 100 also or 40 also. Yes or no? The 5 questions
Yes.
you are not sure. It could be totally upside down. What you thought was 10 on 10, you can get 0 on 10. Something which you thought 0 on 10, you can get 10 on 10. So your confidence level will go down. Difference will increase. Deviation will increase. Deviation difference will not decrease. This is what you are calculating, and this is what you got. Difference is less. This is what you are calculating. This is what you got. Deviation is high. Standard deviation less means the difference is less. Deviation is less. The name itself says difference, deviation. Deviation means your deviation will be higher when you are not sure. Okay. So now, when will this number increase? If you have something by something, A by B, right? We did A by B here, right? When you do A by B and you get X, in which all cases X will increase? A increases, X will increase. Or B decreases, X will decrease. So what we have done, since we are not sure, we ourselves are putting error into the process. We are saying, okay, I'm not sure, so I'm going to put error into my process. Instead of saying 70, you will say I might get 65 to 75. You're increasing the so that's what we do. When we calculate for population, you are very sure about everything. We use n. Average is by n. But when you are not sure, you are saying n minus 1. Minus 1 because you want to increase the deviation. You are not sure. So you are bringing in higher error into the process. So that's why sample variance is always n minus 1 in the denominator. Makes sense, guys? Okay.
Yes,
So
sir.
we'll stop here. Okay. So today we have seen range, IQR, variance, and standard deviation. Okay. So, and we have already discussed median. Quintile is dividing into 5. Quintile is dividing by 5. Decile is dividing by 10. Percentile is, this is percentile, okay, spelling mistake. Percentile is dividing into 100. So median is dividing into half. Quartile is dividing into 4. Quintile is dividing into 5. So you have 20%, 20%, 20%, 20%, 20%, 20%. Decile is dividing into 10. So 10%, 10%, 10%. So in practically we use median, quartile, and percentile. Okay, quintile, deciles generally we don't use, but you know that they exist, right? And this is what we do. So tomorrow when we meet, we'll talk about which is best and how do you combine median mode with standard deviation and analyze the data. So hopefully by tomorrow or by next week, we'll finish off our basic statistics and we'll move to visualization. Shall we end it here, everyone?